Space and Science News with James. In the depths of space, billions of miles from Earth, a cosmic drama unfolds. A small, icy world, once celebrated as our solar system's ninth planet, now finds itself at the center of a heated scientific debate. This celestial body, smaller than our own moon, has sparked controversy, challenged our understanding of the cosmos, and even inspired public protests. Its name? Pluto. For decades, Pluto held its place in the planetary pantheon, a distant sentinel in the outer reaches of our solar system. But in 2006, everything changed. In a decision that reverberated throughout the scientific community and beyond, Pluto was stripped of its planetary status. The repercussions of this celestial demotion are still felt today, raising profound questions about how we categorize the worlds that populate our cosmic neighborhood. Today, we'll be talking about the Pluto problem and whether it's time to rethink our definition of a planet. Because why not? After all, the classification of celestial bodies might seem like a purely academic exercise, but it goes to the heart of how we understand our place in the universe. What exactly is a planet? Is size all that matters, or should a planet's influence on its surroundings play a role? And what about the countless worlds we're discovering around other stars? As we peel back the layers of this cosmic conundrum, we'll uncover a story of scientific progress, heated debates, and the ever-evolving nature of our understanding of the cosmos. Let's dive deep into this subject and explore the fascinating world of planetary classification, where the fate of Pluto hangs in the balance. In the vast cosmos that surrounds us, few celestial bodies have sparked as much controversy as Pluto. Once hailed as the ninth planet in our solar system, Pluto's status underwent a dramatic shift in 2006 when the International Astronomical Union, IAU, redefined what it means to be a planet. This decision sent ripples through the scientific community and beyond, leaving many to wonder, is it time to rethink our definition of a planet? The story of Pluto's demotion is a tale of scientific progress and evolving understanding. For decades, Pluto held its place as the furthest known planet from the Sun, discovered in 1930 by Clyde Tombaugh. Its icy surface and eccentric orbit made it a fascinating subject of study, capturing the imagination of astronomers and the public alike. However, as our technology advanced and our view of the solar system expanded, questions began to arise about Pluto's true nature. The discovery of numerous other objects in the outer reaches of our solar system, particularly in the region known as the Kuiper Belt, forced astronomers to reconsider how we classify celestial bodies. The debate came to a head at the 2006 IAU General Assembly in Prague. Here, astronomers from around the world gathered to establish a formal definition of a planet, a task that had never before been undertaken in the history of astronomy. The discussions were heated, with two main camps emerging: the geophysicists and the dynamists. To truly understand the Pluto controversy, we must first delve into the history of planetary classification. The concept of planets has evolved dramatically since ancient times, reflecting our expanding knowledge of the cosmos. In ancient Greece, the term planet originated from the Greek word planets, meaning wanderer. To the naked-eye observers of antiquity, planets were simply celestial bodies that appeared to wander against the fixed backdrop of stars. This definition included not only what we now consider planets but also the Sun and the Moon. The Copernican revolution in the 16th century marked a significant shift in our understanding. As Earth was recognized as a planet orbiting the Sun, the definition of planets began to change. The Moon was reclassified as a satellite, while the Sun took its rightful place at the center of our solar system. For centuries, this new understanding served astronomers well. The known planets, Mercury, Venus, Earth, Mars, Jupiter, and Saturn, fit neatly into this model. However, the dawn of the telescope era would soon complicate matters. In 1781, William Herschel's discovery of Uranus expanded the known boundaries of our solar system. Initially thought to be a comet, Uranus was soon recognized as the seventh planet. This discovery was followed by Giuseppe Piazzi's identification of Ceres in 1801, initially classified as a planet orbiting between Mars and Jupiter. As more objects were found sharing similar orbits with Ceres, astronomers faced a dilemma. The concept of planets living in solitary orbits was challenged, leading to the creation of a new category, asteroids. While Uranus maintained its planetary status, Ceres and its companions were reclassified, setting a precedent for future debates about planetary classification. The discovery of Pluto in 1930 by Clyde Tombaugh seemed to reaffirm the traditional view of planets. Initially hailed as the ninth planet, Pluto was welcomed into the planetary family with great excitement. However, from the beginning, there were signs that Pluto was different from its planetary siblings. Pluto's orbit was notably eccentric, sometimes bringing it closer to the Sun than Neptune. It was also tilted at a greater angle to the ecliptic plane than the other planets. These peculiarities were initially overlooked in the enthusiasm of discovery, but they would later play a crucial role in Pluto's reclassification. As our understanding of the outer solar system grew, particularly with the advent of more powerful telescopes and space probes, astronomers began to realize that Pluto was not alone in its distant realm. The discovery of the Kuiper belt in the 1990s revealed a population of icy bodies beyond Neptune, many sharing similar characteristics with Pluto. The real turning point came in 2005 with the discovery of Eris by astronomer Mike Brown. Eris, slightly more massive than Pluto and orbiting even further from the Sun, forced astronomers to confront a difficult question: if Pluto was a planet, shouldn't Eris be one too? And if so, how many more potential planets might be lurking in the outer solar system? These discoveries set the stage for the fateful IAU meeting in 2006. Astronomers were faced with a choice: either expand the family of planets to potentially include dozens of new members, or establish stricter criteria that would exclude Pluto and its Kuiper belt companions. After much debate, the IAU settled on a definition that required a planet to meet three criteria: it must orbit the Sun, have sufficient mass to assume a nearly round shape, and have cleared the neighborhood around its orbit. While Pluto met the first two criteria, it failed the third, sharing its orbital neighborhood with numerous other Kuiper belt objects. The reclassification of Pluto as a dwarf planet sent ripples through the scientific community and beyond. While many astronomers accepted the new definition as a necessary step in categorizing our complex solar system, others viewed it as an arbitrary decision that ignored important aspects of planetary science. One of the main criticisms of the IAU definition is its focus on orbital dynamics rather than the intrinsic properties of the body itself. Some scientists argue that a planet should be defined by its geophysical characteristics, namely, whether it's large enough for its own gravity to pull it into a nearly spherical shape. This definition would not only reinstate Pluto as a planet but would also elevate several other bodies, including Ceres in the asteroid belt and potentially some moons of the gas giants. Another point of contention is the requirement for a planet to have cleared its orbital neighborhood. Critics argue that this criterion is poorly defined and even problematic when applied strictly. After all, Earth shares its orbital neighborhood with thousands of asteroids, and Jupiter's Trojan asteroids occupy the same orbital path as the gas giant. The debate has extended beyond purely scientific circles, touching on issues of culture and history. Pluto's planetary status had been ingrained in public consciousness for over 75 years, and its demotion was met with surprise and sometimes dismay by the general public. This reaction highlights the complex relationship between scientific classification and cultural understanding. Some astronomers have proposed alternative classification systems. For example, a geophysical definition would categorize planets based on their internal structure and processes, potentially creating subcategories like terrestrial planets, gas giants, ice giants, and dwarf planets, all under the broader umbrella of planets. The controversy has also sparked renewed interest in the outer solar system. The New Horizons mission, which flew by Pluto in 2015, revealed a complex world with diverse landscapes, atmospheric phenomena, and potential geological activity. These findings have led some to question whether our current categorization truly captures the nature of these distant, fascinating worlds. As we look to the future, the debate over Pluto's status, and the broader question of how we define planets, continues to evolve. This ongoing discussion reflects the dynamic nature of science itself, constantly adapting to new discoveries and changing perspectives. The exploration of our solar system is far from complete. With each new mission and technological advancement, we gain fresh insights into the nature of planets, dwarf planets, and other celestial bodies. The James Webb Space Telescope, for instance, promises to revolutionize our understanding of distant worlds, both within our solar system and beyond. The search for exoplanets, planets orbiting other stars, has added another layer of complexity to the planetary definition debate. We've discovered a wide variety of planetary systems, some radically different from our own. These findings challenge our Earth-centric view of what constitutes a planet and may eventually necessitate a more flexible, inclusive definition. Moreover, the study of planet formation and evolution continues to provide new insights. We're beginning to understand that the distinction between planets, dwarf planets, and other small bodies may be more of a continuum than a set of discrete categories. This realization could lead to a more nuanced classification system in the future. The Pluto debate has also highlighted the importance of public engagement in science. The passionate response to Pluto's reclassification demonstrates the deep connection many people feel to our cosmic neighborhood. Moving forward, astronomers and educators face the challenge of communicating complex scientific concepts while respecting this public sentiment. Ultimately, the goal of planetary science is not just classification, but understanding. Whether Pluto is called a planet, a dwarf planet, or something else entirely, it remains a fascinating world worthy of study. The debate over its status has spurred new research, new missions, and new ways of thinking about our place in the cosmos. As we continue to explore the outer reaches of our solar system and beyond, we must remain open to revising our definitions and categories. The universe has a way of surprising us, and our understanding must be flexible enough to accommodate new discoveries. The story of Pluto reminds us that in science, as in the cosmos itself, change is the only constant. The story of Pluto is more than just a scientific classification debate. It's a testament to the dynamic nature of scientific understanding, a reminder that our knowledge is always evolving, always changing. What we consider absolute today might be challenged tomorrow by new discoveries, new technologies, and new perspectives. Pluto stands as a symbol of scientific curiosity, challenging us to look beyond rigid definitions and embrace the complexity of our cosmic neighborhood. Whether it's a planet, a dwarf planet, or something entirely different, Pluto continues to captivate scientists and space enthusiasts alike. Its complex surface, its unique orbit, and its place in the outer solar system tell a story far more interesting than any simple classification could capture. The debates surrounding Pluto reveal something profound about scientific progress. Science isn't about establishing unchangeable facts, but about continuously questioning, exploring, and refining our understanding. Each new discovery pushes the boundaries of our knowledge, forcing us to reconsider what we thought we knew. If you've enjoyed this deep dive into the world of planetary science, we'd love to hear your thoughts. Do you think Pluto deserves its planetary status? Are scientific classifications too rigid, or necessary for our understanding? Don't forget to hit that subscribe button and notification bell to stay updated on our latest explorations of the cosmos. Drop a comment below, share your perspective, and join our community of curious minds. Until next time, keep looking up and wondering about the incredible universe we call home. Thanks for watching. Remember to like, subscribe, comment, share, and click that notification bell so you never miss out. See you next week.